All right, today we're going to be looking at writing and graphing inequalities. We won't actually be solving any at this point today, but we will be doing an introduction and some examples on really just converting a scenario into mathematics and graphing that as on the number line. So first, let's take a look at just a reminder of what these symbols mean. And you know, back in maybe in middle school or in elementary school, you had lots of tricks and ways of remembering what these symbols mean. Some involved alligators. Sometimes people talked about the less than sign looking like an L for less than. I don't really care which method you use. I'm just going to remind you of them and expect that you can remember them. Okay. So first one is a greater than sign or more than. And this is a greater than or equal to sign. This is also an at least symbol. It means at least. This third one is a less than symbol. And the final one is a less than or equal to. And also can mean at most. Okay, so that's just a quick reminder of what the symbols mean. So let's practice just converting some maybe real-world statements into mathematics, into using inequalities. Okay, so this first one over here in our example, I want to earn at least $10 per hour. I'm not going to formally define variables here, but let's say that's my hourly wages, W. I want it to be greater than or equal to 10. And just as I think a reminder, it might be obvious to you, but I think it's important to just be explicit here that when we're solving an inequality, when we're working with an inequality, there are often, usually, maybe always, an infinite number of solutions. So I want to earn at least $10 per hour. $10 works. $10.01 works. $20 works. $35.50 works. So there are an infinite number of possible wages that earn at least $10 per hour. Okay. Tonight I can have no more than 3 hours of homework. So no more than also means at most. Okay, so this no more than also means at most. And so that's going to be my hours must be less than or equal to 3. Next one, I want to earn a GPA that's greater than 3. So that implies that if you earn a GPA that's exactly 3, it wouldn't meet your needs. It wouldn't cut it. Okay. So you want to earn a GPA that's 3.01, 3.5, anything bigger than 3. So let's call it G for GPA has to be larger than 3 or greater than 3. And then lastly, I want to buy a car for less than $2,500. If you found one for exactly $2,500, presumably you wouldn't want it, okay, or you wouldn't be able to afford it. So we want it to be less than $2,500. So the cost of the car is less than $2,500. Okay, I think the trick here with inequalities is to just make sure that you're familiar, especially with these, with the at least and the at most terms, or the no more than terms. Okay. Let's do a couple more examples. One thing that you can end up doing is you can check a solution and see if this solution works. It creates a valid inequality. And like I said before, there are often many, many solutions that will work. So negative 3x plus 2 is greater than 17. Let's plug in a 0. Negative 3 times 0 is 0, plus 2 is not greater than 17. 2 is not greater than 17, so that does not work. Let's plug in a 25. We'll just do all this with mental math. Negative 3 times 25 is negative 75. The 2 isn't even going to matter there. Negative 73 is not greater than 17, so that one does not work. Let's try negative 50. Negative 50 times negative 3 is 150, plus 2, 152. Yep, definitely larger than 17. And a negative 5. Let's see, a negative 5 times negative 3 is a 15, plus 2. Is that larger than 17? No, it's not. It's equal to 17. So in this case, it doesn't count. Okay, it doesn't work. So of the 4 solutions I listed, only 1 is valid, although there are many more that are valid that I didn't list. Graphing solutions, x is greater than -2. We use a symbol here. Well, let's get a number line in here. And for a lot of these, you can set up your number line however you want. I usually just start with the number that we're given here. It's a -2, and throw in a few numbers on either side. So when x is greater than -2, that means x cannot be -2. So we put an open circle, and greater than on a number line is to the right, and we'll draw an arrow. So any of those numbers from -2 and larger will work as long as we don't include -2 itself. X is less than or equal to 3, so we'll throw in a 3 here, put in a couple numbers on either side. 3 is allowed, okay, so that's a solid circle, a solid dot, and then we're going to the left, so x is less than or equal to 3. Okay, sometimes we use the words inclusive or exclusive, so maybe not, that's not quite formal math language, but on this first example, x is greater than -2, you might say something like x is larger than -2, excluding or exclusive of -2. And in the second example, you might say x is less than 3, inclusive or inclusive of 3. This next one is what I call a between or an and inequality. It's an example of a compound inequality. And we can kind of cover it up and look at it in two ways. This says 4 is less than x, which really also means x is greater than 4. Okay. And then this second bit over here, x is less than or equal to 7, which we don't have to rearrange, is simply x is less than or equal to 7. And this, when they're written in one inequality, it means both of those things have to be true. And so this I call a between or an and inequality. So let's set up a number line. It looks like we need to go 4 to 7. And we have an open circle at 4 and a closed circle at 7. And then a line in between them. So any of those numbers, not including 4, but from 4 to 7 are valid answers, including decimals, fractions, irrational numbers between those two numbers. Okay. And this last one is I call it an or a beyond inequality. X is less than or equal to -1, and then also x is greater than 2. So let's throw in a -1, -2, 0, 1, 2, 3. And so we know that x can be -1 or smaller, or x can be 2 or larger, not including the 2. And of course, those things can't both happen at the same time, so this is an or inequality. Next one is interpreting a graph here, and we'll connect back to what we were just working on here. This first one is a between problem, so I'm going to write it as a compound inequality with a -2, an x, and a 5. And then let's think about what our signs are looking like. This is a less than or equal to sign, and this is a less than sign. Okay, so I'll try to highlight just it piece by piece. This is saying that x is larger than or equal to -2, which is another way of saying that -2 is less than or equal to x. And this is saying, obviously, that x is less than 5. So it's a between problem. Okay. And this last one is a beyond or an or problem. It looks like we have x is less than -1, or x is greater than or equal to 2. Okay. Not and, it's not an and problem. Both of those things can't happen at once. It's an or problem. One or of the other has to be true. And that's a good place to stop right there.